Grade 12 learners, how are you today? We hope you're staying healthy and safe. By the way, I am Mr. Carl Historilio. I am your teacher in physics. Learners, today we're going to discuss the scientific figures. Here are the objectives. At the end of the lesson, the learners will be able to explain the concept of the significant figures, define rules for determining the number of significant figures in a measured quantity. Learners, let's just have a short or a quick review what we talked about yesterday. Learners, anyone can still remember what we talked about yesterday, or what did we talk about yesterday? Very good. As we talk about the 20 branches of physics, here are learners. Did you know, in terms of identifying measured value with the correct number of significant digits requires that the instrument's calibrations be taken into consideration. The last significant digit in a measured value will be the first estimated position. For instance, a metric ruler is calibrated with the numbered calibrations equal to 1 centimeter. In addition, there will be 10 unnumbered calibrations marked between each numbered position. This would be referred to as minor calibrations. Learners, before we proceed to the definition of scientific figures, let me ask you what comes into your mind when you hear about scientific figures. Learners, anyone can share their ideas? Impressive. Who else? Impressive. All of this or all of the following are correct about scientific notation. At this point of time, I will give you the definition of scientific figures. Learners, do not hesitate to ask in case you have any questions, or if you have questions, please feel free to interrupt. Learners, moving on or moving forward, by the definition of significant figures are those digits in a number that are known with certainty plus the first digit that is uncertain. Next, digit pertains to one of 10 Arabic numerals 0 through 9 that are used to represent numbers in the decimal system. Next, trailing zeros are a sequence of 0 in the decimal representation, or more generally in any positional representation of a number, after which no other digits follow. Rules for determining the number of significant figures. Rule number 1. All non-zero digits are significant. For instance, 1.423 meters, there are 4 significant figures. Next, 5.96 meters, there are 3 significant figures. Rule number 2. Zeros between non-zero digits are significant. For instance, 90,412 kilometers, there are 5 significant figures. Then 7.09 milliliters, there are 3 significant figures. Rule number 3, leading zeros to the left of the first non-zero digits are not significant. The zeros merely indicate the position of the decimal point. For instance, 0.008 degrees Celsius, there is only one significant figure. Next, 0.045 grams. There are two significant figures. Rule number 4. Trailing zeros that are also to the right of a decimal point in a number are significant. For instance, 0.750 milliliters, there are three significant figures. Next, 0.50 grams, there are two significant figures. Rule number 5. Trailing zeros, those bounded only on the left by non-zero digits, may or may not be significant. For instance, 3,000, there is only one significant figure. Next, 300, there are three significant figures because the bar indicates that the number is accurate to the nearest hundred. Next, 45.0 meters, there are three significant figures. Continue. 4,580 meters, there are three significant figures. Then, 85.0 meters, there are three significant figures. Learners, to continue, the use of scientific notation will help in determining whether the trailing zero is significant or not. For instance, 5.5 meters can be written as 5.5 times 10 to the 1 power meters. 6,700 kilometers can be written as 6.7 times 10 to the 3rd power kilometers. And 35,900 kilometers can be written as 3.59 times 10 to the 4th power kilometers. Learners, moving on now to addition and subtraction or subtraction. In adding and subtracting or subtracting, the answer can only show as many decimal places as a measurement having the fewest number of decimal places. For instance, when adding 17.21 kilometers plus 18.31 kilometers plus 9.9 kilometers. In the given problem, 9.9 shows the least number of decimal places. Hence, the final answer must be rounded by one decimal place. The answer is 45.42. Round up to one decimal place. The answer will be 45.4 kilometers. Learners, in multiplying and dividing, the answer may show as many significant digits as the multiplied and divided measurement. The final answer must show only the least number of significant digits. For instance, when multiplying 23.38 kilometers times 8.70 kilometers times 12.41 kilometers. Remember, 23.38, there are four significant figures, and 8.70, there are three significant figures, while 12.41, there are four significant figures. The final answer must only have three significant figures because that is the least number of significant digits in the problem. The answer is 2,524.26846, which shows 9 significant digits. We must round up to the nearest 10 to have 3 significant digits only. Hence, the final answer is 2,540 meters. Learners, In sample number 1, it is addition. We have 2.51 kilograms plus 3.13 kilograms plus 1.11 kilograms. So learners, what is your answer? Brilliant! Remember, 2.51, there are 3 significant figures, and 3.13, there are 3 significant figures, while 1.11, there are 3 significant figures. The answer must have the same number of decimal places as the measurement with the least number of the decimal places. The answer will be 6.75 kilograms. Learners, in sample number 2, it is subtraction. In this problem, we have 419.15 kilometers minus 62.614 kilometers. So learners, what is your answer? Impressive! Remember, for 119.15, there are 5 significant figures, while 62.614, there are 5 significant figures. The answer must have the same number of decimal places as the measurement with the least number of decimal places. The final answer will be 356.530 kilometers. Learners, in sample number 3, it is multiplication. In this problem, we have 124.23 kilometers times 13.11 kilometers. Learners, what is your answer? Very good. Remember, 124.23, there are 5 significant figures, while 13.11, there are 4 significant figures. The final answer must only have 4 significant figures because that is the least number of significant digits in the problem. The final answer will be 1,628 kilometers. Learners, in sample number 4, it is division. In this problem, we have 458.12 milliliters divided by 2.52 milliliters. So learners, what is your answer? Impressive! Remember, for 158.12, there are 5 significant figures, while 2.52, there are 3 significant figures. The final answer must only have 3 significant figures because that is the least numbers of significant digits in the problem. The answer will be 181 milliliters. Learners, do you have any questions with regards to scientific figures? If there's none, I hope all of you learned something new today. Learners, anyone can summarize based on what you have learned from this day's discussion. Impressive. To sum up, we discussed about the concept of scientific figures, then the rules for determining the number of significant figures in a measured quantity. Learners, to test your skills, so what are you going to do? Well, you have to identify the number of significant digits in each of the following. In number 1, how many significant figures are there in 340.8 milliliters? So learners, what is your answer? Impressive! The correct answer, there are 4 significant figures. In number 2, How many significant figures are there in 1,248.84 kilometers? So learners, what is your answer? Impressive. The correct answer, there are 6 significant figures. Learners, in number 3, how many significant figures are there in 95 million kilometers? So learners, what is your answer? Brilliant! The correct answer, there are 2 significant figures. In number 4, how many significant figures are there in 2,300 grams? So learners, what is your answer? Brilliant! The correct answer, there are 3 significant figures. In number 5, how many significant figures are there in 0.009 grams? So learners, what is your answer? Brilliant! The correct answer, there is only 1 significant figure. Learners, at this point of time, let us test new learning skills. Try to answer the following question. Then you have to identify the number of significant digits in each of the following. Put your answer on the line provided. 2 points per question. Learners, keep calm and good luck on your quiz. Learners, that's the end of our lesson for today. Thank you for listening. We hope you enjoyed and learned something new today. Stay at home, stay safe and healthy. Goodbye and have a great day. God bless you all.